Alright, so we got this push-up problem, so we're doing a class and we want to test if there's evidence at 90% level that boys can do more push-ups than girls. Now, the deal here is it's not the same person doing both samples, so this is not a paired sample. So this is a 2-sample T interval. Okay? So we're going to go ahead and test this out. So here we go. So so our parameters here are U of M is the mean number of push-ups a high school male can do. And U of F is the mean number of push-ups a high school female can do. So our assumptions, these samples are not random, but they are representative. These samples are independent. They're not matched. In other words, the number of push-ups that the females can do did not affect how many the males can do. So in this case, we have what do we have? 2, 4, 6, 8. Looks like we have 13 males. So there were 12 males and 12 females. Okay. So 12 males and 12 females are less than 10% of all high school males and females. And then we got to test the normal distribution. So L1, let's see what that looks like. Oh, got the wrong thing on. Let's plot. Let's do a histogram and zoom 9. Okay, so that's the males. That's roughly unimodal and symmetric. And then we would copy that down, and then let's change this to L2 for the females, and we're going to do zoom. Okay, so that's roughly unimodal and symmetric. So both of them are roughly unimodal and symmetric, and you would copy those both down on your paper. Name the test. This is a 2-sample T interval, and we got to get the mean for males, the standard deviation for males, and the number for males I already know is 12, and the mean for females, the standard deviation for females, and the number for females I already know is 12. So let's do that. Stat calc, one of our stats, L1. This is for males. 23.83 is the mean, and standard deviation is 7.21. So that's 7.21. This is 23.83. And then let's do the females. And their mean is 16.5. Standard deviation is 8.94. All I did there is when I did one of our stats, I just pushed L2. So that's all you do. You change it from L1 to L2, and there's your female deal. Alright, so that's the females. The interval, we're going to do x bar sub 1 minus x bar sub 2 plus or minus t, and we got to figure out how many degrees of freedom we have. And then what we're going to do is we got to add the variances, right? So we got to do 7.21 squared over 12, because we squared that. We took s over the square root of n and squared it, plus 8.94 squared over 12, and that's our deal. So now we got to figure out how many degrees of freedom that is, and we'll get that in a minute. So I'm going to go through and I'm going to run that test. So that's a 2 prop. No, it's not a 2 prop. 2 sample t interval. So list 1 is L1, list 2 is L2. Doing a 90% interval. I'm not pooling. Calculate that up, and we get from 1.63 to 13.04. And yeah. So the degrees of freedom is 21. So I got that also. So I'm going to calculate that in a second. So let's see if it's 1.63 to 13.04. Now I want to know what that t value is. So 90% confidence interval. Again, I always draw myself a little picture if you don't mind. 90% we shade in. So that means that starts at the 5th percentile and ends at the 95th percentile. Okay, so I'm going to do stat and second distribution inverse t, and I'm going to do 0.95 with 21 degrees of freedom, and my t value is 1.721. So this is really 1.721, and the conclusion is we are 90% confident that the average number of push-ups a high school male can do is between 1.63, and again we're talking averages, 13.04, more than the average number of push-ups a high school female can do. Okay. Now if I wanted to do a hypothesis test, my hypothesis would be mu of males equals mu of females, and then my alternative hypothesis would be mu of males is greater than mu of females. Now we've already tested the conditions. The name of this would be a 2-sample t-test. My t-value would be the mean of the males, which is 23.83, minus the mean of the females, minus my hypothesized difference, which would be 0, over, now I got to add the variances again, 7.21 squared over 12 plus 8.94 squared over 12. Now, again, when we did our interval, we didn't get 0 in the interval, so when I do a two-sample t-test, I'm doing a one-tail test here. This should wind up rejecting the null. So let's see what happens. Go to stat test. I'm going to do a 2-sample t-test. I'm going to use the data from L1 and L2. I'm doing that L1 is greater than L2. And I'm going to say, okay, calculator, draw that out for me. And it still has my histogram in there, but that's okay. It's not. Okay, so what do we get? A p-value of 0.02 and a t-value of 2.21. So a t equals 2.2 and p is 0.02. So what do we wind up doing? We wind up rejecting the null. So there is evidence that the mean number of push-ups that a high school male could do is more than a high school female, which is exactly what our confidence interval found. So those two wind up supporting each other.